All right, three more questions to be answered in this one. Number one says K is a positive constant and they want the area of the region between the x-axis and the graph. So what I'm going to do is graph this. I see that I can factor out an x squared, which leaves me with a k minus x. And then that means, because this is a polynomial and I have an x squared here, I'm going to have a double zero. Let me change colors. A double zero right there at 0. Then they told me k was a positive constant, and so k minus k will give me another 0. So my positive constant is k, and that is going to be an x-intercept. Then, because my function is a negative leading coefficient and an odd degree, it's going to have this end behavior, up to the left, down to the right, so I can kind of connect the graph. And I did that because it enables me to see the region for which I'm finding the area. And that region is going to be the integral from 0 to k of the function kx squared minus x cubed dx. And this is really not a calculator problem, so I'm just going to keep on going by hand. I go up a degree to x cubed over 3, and then I have minus x to the 4th over 4. I'm going to evaluate it from 0 to k. And when I do that, k goes in here and I get k to the 4th over 3 minus k to the 4th over 4. And I will have to get a common denominator of 12. So this will be 4k to the 4th minus 3k to the 4th over 12, which means my answer is k to the 4th over 12. All right, the next one requires u substitution, and you just have to recognize that tangent differentiates to secant squared. So my u here is going to be 1 factor of tangent, and my du will be secant squared x dx. And then I could do a nice substitution, simple substitution, and put in u for tangent, make it squared because my tangent is squared here. And then for secant squared x dx, I put in a du. That integrates to 1/3 u cubed plus c. And of course, I need to sub back in tangent for that. So I'm going to have 1/3 tangent cubed plus c. And then the last problem is we have a particle moving along a straight line. It's given by this function, and they want to know acceleration at time equals 1. Well, this is position. This is an FTC Part 2 problem because I've got a variable in my upper limit of integration. So to get to s prime, which is velocity, I just have to plug t in for u. So I get 1 over t squared plus 1. Then acceleration is t double prime. So I have to differentiate this, which is going to give me 1 over t squared plus 1 squared. And really, I just want to point out, I rewrote this as t squared plus 1 to the negative 1. So I bring down a negative sign and then drop the degree to 2. And then I need to multiply by the derivative of my inside function, which is 2t. So that is my acceleration, and I need acceleration at 1. So I'm going to do a such that t equals 1. Hard to fit that in there. But that my numerator then gives me a negative 2. And my denominator gives me 2 squared is 4. So my answer will be negative 1/2.